Hello everyone. So the homework on the RSA protocol and 25 and 26 are basically the same question. So one is encrypting, one is decrypting. So we have, they want us to use, so I will use green, M to be 53 times 61. Now be careful, we should not publish the 53 and 61. So that is, sorry, 53 times 61, 53 times 61, so this is 3233, and that actually is the two prime numbers that we're going to use are 53 and 61. Okay, and what else? And E, they tell us, is 17. Now, if they tell us that E is 17, we have to trust that it's a valid number. So let's double check what is the condition on E. There's only one condition. As I said, it's a rather light condition, and a randomly taken number often satisfies this. So no, okay. So what you calculate is this capital N, that is 52 times 60. Right? You take, so this is P, and this is Q, and this is P minus 1 times Q minus 1. That is what it's supposed to be. Okay. So you take a random number. Of course, for one thing, you know that this capital N is always going to be an even number, because our primes are odd numbers, and subtract from one of it. In fact, it's always divisible by 4. So you should not consider even numbers, but an odd number, very often it works. Especially if you take a little bit bigger, like 17 or something like that. And so it's not so hard to see that 17 is relatively prime with 52 and 60. Okay, so that's the data, and now we want to transmit the message that we want to transmit, or Bob wants to transmit. I always think of Bob sending it to Alice, whatever the textbook says. Let's keeps our head straight that way. He wants to send the message upload. Now, we didn't discuss this in detail, but what we need to do, we know that this is every letter is represented by an element of Z26. So from 0 to 25. So every two letters will be a number. So one letter that is from 0 to 25. Two letters will be, well, technically from 0 to 25, right? You could have just ZZ if you want to. 00 would be AA, and 25 would be ZZ. And so what we always need, therefore, if we're going to do two letters, we can, as long as this number that we need here, then for two letters we need up, this will, all possibilities will be from 0 to 25. It has to be always smaller than that. Okay, that's why we cannot treat three letters. So what would three letters do? It doesn't work, because three letters will go from 0 to 25. Z. If you want to encode it, the z, it would not work, because this number is too big, meaning that the residue, the remainder mod 2333 is not unique, and so there are many numbers here that will have the same remainder mod 3233. So that's something we cannot allow. So that's what this explained a bit more in the book. I didn't pay that much attention to it, because for us it is really just numbers that we transmit. But if you really want to do letters, then that's what you have to do. And then you have, so in other words, you can do two letters. So we have to break this down in 3 blocks of 2 letters. So up, load, low, and AD. So we have to calculate the values of this. Yeah, I wish I had kept a table, but I didn't do. So we have to do quickly the alphabet here. I'll do it here. So let me take a different paper that I don't have to drive lines. That's what we do. Yeah, okay, here we go. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, and I don't think that's it, right? 0, 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, So up would be the message 20, and P would be 15. LO would be the message 11, 14. And add, and this is perhaps what I should stress here, A is 0 and D is 3, but we cannot just put 0, 3 here. Well, we can, yeah, this is actually not really what I wanted to say. Okay, so what we really need to do is always think of every letter as a 2 digits. So that would be 0003. Now, I admit that is the same thing as what I just said, but this is how you encode it. So this is 3. Okay, that's the message that we will, or the numerical value of the message will be encode. But I wanted to say this, for instance, suppose we would have to do also LA. Okay, L would be 11 and A would be 0, but we cannot write 110 because 110, if we see 110, we should interpret 110 as 01, 110. Right? So if we get a number, we always pad it with zeros in the front. That doesn't change the value, right? If we put a 0 in the back, it changes the value. So we have to put it this way. So if we write 110, we would interpret this as 0110. So we say, oh, that is the same as this one because we need to have the right length. And then 01 stands for B and 10 stands for K. So we would misinterpret this. So this is wrong. Sorry, I should perhaps indicated this. Let me put a big red cross to it. What we have to do if we do LA, we have to encode LA as L is 11 and A is 00. Okay? And this is especially important if you have more letters. Now, this is a technicality that it's nothing to do with the actual problem, so I'm not going to spend too much time on it. Here we are, we have these 3 numbers, and what we have to do to calculate, we're going to take that value, put it to the power 17, and reduce it modulo 3233. Okay, so modulo this modulo. So that's what we have to calculate. Okay, so that's always orange for us, right? So we have that was the wrong orange. Let me remove this guy because it confuses me. Okay, so this is supposed to be okay. No, okay. All right. So it is 2015 to the power 17. That would be let's do it. 17 is actually not such a bad power to work with because 17 is 16 plus 1. Okay, so if we would do sorry, I'm going to do one by hand and the other ones I'm going to do calculate with a calculator. The problem says, the textbook says that you, or the the homework problem says that you can use some tool here, but just to see it once. What is it? What are the steps? We would take 2015. Modulo 3, so we would calculate this, and we would calculate here modulo 3233. So this is 2015. Then we take 2015 squared. And that, of course, we have to calculate. 2015. There's something wrong with my iPad. It doesn't. 2015. Okay. Square this. Where is my square now? Okay, that is 4060225, so 4 million, etc. And so we divide this now by, it has changed, right? Sorry, I don't know, my calculator is acting up. 2015 times 2015, okay, that's the number I said, divided by 3233, that is 1250, so that is 1255 times 3233 plus 1255 times 3233, that is 400, that is, okay, and what is remains, I'm going to write it down, 4060225, 2018 plus 200810. Okay, and that's the square, Now 2008-10, yeah, okay, you could subtract, it makes it slightly less, but not that much. We will only do this if you can really get only 1 or 2 decimals instead of digits, instead of 4 digits. But okay, let's square it again. Sorry, this would be the 4th power, which is, no, that's not what we need. We need to keep doing this. So 2018 squared divided by 3233, that is 200, this is, oh, sorry, okay, I am not going to do it over again. It's 2000, this is this number squared, sorry, 2008-10 squared is equal to that plus, so 2442 times 3233, that is that, and oh shoot, yeah, I should have written down that number, 2008-10 times 2008-10 is 11, so plus 1114, okay, then 2015 to the power 8, that is 1114 squared, okay, squaring this, that is 124096 divided by 3233, that is 383 times 3233, and subtract this, that is 124096, that is 2700 plus 2775, okay, and then finally we also, this is still 2015 to the power 16, so we have to do 275 squared, that is 760,1049 divided by 3233, that is, yeah, I don't know why I'm getting myself such little space here, so this is 2351 times 3233, 2351 times 2, no, okay, 2351 times 3233, that is that, and then 760,1049, what is he doing again? 2351 time. My iPad, sorry guys, I'm trying to do too fast. Let me do this. 2351. This is kind of stupid what I'm doing because you don't see anything and I'm getting frustrated because my iPad is getting me. That is, yeah, and so 760,1049, that is 266. So this is going to be the same as, so what are the powers that we have to do? Well, we know that it is 16 and 1, so it's this guy and this guy. Okay, so this is 266 times 2015. So 266 times 2015 divided by 3233, that is 165, that is 165 times, sorry, I should have written that down, okay. (266) times 2015, that is 5,35990 divided by 3233, that is 160. It's 165 times 3233. That is, then the difference is 535 990. I'm sorry, guys. 165 time. I'm not gonna do this anymore. 3233 and subtract from that 535 990. No, I'm sorry. I cannot do a simple multiplication with my 3233. Okay, this number is 533445, and for some reason I cannot subtract the other number from 5990. Finally, 2545. So that is our answer. Now I'm going to double check this because I have no trust in my calculation anymore. This was horrible what I did. Okay, so let's double check this with Wolfram Alpha. So what was the number I would do? 2015 to the power 17, and that was modulo 3233. And the answer was 2545. I'll be damned, that was correct. Okay, so C, the corresponding, so this was up, the corresponding value was 2545. Okay, and so we can do this for, this is C1, let's say the first one, the second one, so let's call this M1. Yeah, I was making a table here, but then I filled it in, so let's put it just here clearly. So this was the C, so this is C, right? C is now equal to 2545. What is it for? So we have to do 1114 to the power 17. Okay, and that as I said, I'm not going to do this anymore. 1114 to the power 17. That is 2757. This is always modulo this number, right? And then it's finally 3 to the power 17. 3 to the power 17. That is 1211. So what he would send, in other words, if he sends this so what he would send is these three numbers in that sequence, right? 2545, 2757, 0121, if you want to make it 4 digits. Okay, so that was the first question. Okay, I just want to double check that is the correct answer. It looks like it was going to be correct, but you never know. With me, you can never trust me. Okay, so now I'm looking in the wrong spot. What is this? 4, this was 46. Oh, that's section 5. 4, 5, okay, 4, 6, and this was number 25. 2545, 2757, 1211. 1211. Just my last one is wrong. 1211. Right, okay, let me do the last one over. 1211, yeah, it is correct. I just copied it wrong. 1211, that's what I actually had, but I just copied it wrong. Okay, so, okay, this is correct. So the first question is done. Now the second question is actually somehow even more interesting, because there it is what we do the actual, how to say, the juice of the thing, namely being able to find out what the message was, right? That's what we want to do here. And so we now receive, so now we take the point of view that we received the message 3185 2038 2460 2550. Okay, that's the message. And so we have to decode this. But what we need, of course, is something that we have not figured out, that is, what is D? And that is where the actual work goes. The rest is again, modular exponentiation, and that one I'm going to do quick, but let's calculate D. So what we know is that D times E has to be equivalent to 1 mod 3 to... No, mod what? Mod this number. Okay, we haven't actually said what that number was, so we do this. 52 times 60. So this is 3120. Okay? As I said, this number, of course, is always going to be rather similar to that in magnitude, right? Because we just subtract 1 from each factor. But it is impossible to guess what this is. You can say, oh, it's 113, so perhaps it's always like that. No, it really depends on the prime speed. In fact, there is an exercise, if you can, I think you can look it up, the answer in the back of the book, that says that if you know n, you can factor little n. Okay, that is kind of surprising, right? If you know this number, you can factor this number. Knowing, of course, that it is equal to p minus 1 till q minus 1. Okay, this is what we have to do. So with the model 312, so this was incorrect, right? So this is 3120. Of course, this calculation, remind yourself of why is it something else. This is a secret calculation, right? Everything here except for this number is secret. So if the modulus would be known, then there's nothing secret anymore. We're going to calculate D. So in some sense, the real secret is this number. If that number is revealed, as I said, you can actually do, but it doesn't matter. If you know this number, you can calculate D, and that's the only thing you need. So this number is somehow the more important one. Don't reveal this one, of course, neither this one, because that gives also. So let's solve this. So E was 17, right? So we have to solve. I'm going to go black and black. So 17D is equivalent to 1 mod 3120, and that means that we have to find the inverse of 17. So we know how to do this. We use the Euclidean algorithm. Okay, so that is 3120 is how many times 3120 divided by 17? That is 183 times 17. Now remember, we're going to have to do this backwards, right? We're going to have to write 1 as a linear combination of these two numbers that have not circled. That's the Bezout form. So I'm doing this already, preparing myself for that. So 183 times 17, that is, this number is 3111, so I'm off 9, plus 9, okay? We don't need this anymore. I can do this right, okay. Okay, so next, there's again the circled number. We do 17 is, well, 1 times 9 plus 8. Okay, then we do 9 is 1 times 8 plus 1, and that is what we want to see. If we don't get a 1 here, then something is wrong, right? Either E was chosen wrong or we made a mistake. So once we have this, we work our way back. That is this was the downwards part, this is the upwards part, right? So 1 is equal to 9 minus, or circled 9 minus circled 8. Then we use this one. So this is equal to circled 9 minus 17 circled minus 9 circled. So grouping together, we get minus minus. So 2 times 9 minus 1 times 17. Now we use this one. So this is 2 times 3120 minus 183 times 17. Or don't forget that you're always subtracting here, right? Because you're always bringing this to the other side. That's why there's a minus here. So that is 2 times 9 and then minus 17. So what is this number? Let me write it up here. It's twice 3120. And then we have 183 times 2 plus 1. So 367 plus minus 367 times 17. It is a minus. So we know now that D is equivalent to this number, right? Because This is 1. Remember, this is 1, right? This is another form of 1. Well, let's double check that it is true. Always double check if we do these things. 6239, and that is 6240. Yes, yes, this is correct. So now we know that D is equivalent to minus 367 times 17 modulo 3120. Okay, we want a positive one, so I'm gonna add it to 1. So 3120, add that 367. So it is actually 2753 mod 3120. So this is what D is. So let's write it down. D is this 2753. So the other big exponent. That's of course not good if you need to do this by hand, but no, I'm not going to do this anymore. Okay, so I'm going to erase this calculation now. We know what this is. Okay. And I want you to do this on a quiz too, right? I want you to show this. As I said, I allow you to do the calculations modulo, the modulo calculations using some online tool or anything else, but then only that, right? Don't cheat too much. Don't cheat at all. Try to be honest with yourself and do it. Anyways, you have to write it down. You have to show me the work. Whenever I say that you have to do something, you have to show me the work. So it's not, you cannot just copy the result here. Otherwise, you're not going to get points for it. Okay, so what we need to do, well, we to decode. So what is the first letter? Well, that is going to be 3185 to the power 2753 modulo 3233. It's always the same. Now this is back to old modulus, the product of the two primes. This the n here, right? That's now the one that we're talking about. Okay. So I said resorting to Wolfram alpha here. So we have 3185. I hope I didn't copy that one. 3185, yeah, 3185 to the power 2753. 2753, I didn't copy that wrong. Oh, I erased that, so I better don't copy it wrong. 2753 mod. Okay, all right, here we go. So that is 1816. So we find that this is 1816. Now this is supposed to encode letters, so let's see what are the letters. 18 is here, right? That's from our table. 18 and 16. SQ. Huh. Okay, this is SQ. So what is the next one? Is 2038 to the power 2753. Mod, I'm not going to write the modulus anymore, so let's do that. 2038 to the power, it's 2008. So this represents, 20 represents the letter U, and 8 represents the letter I. What is it trying to say? Squee. Okay, squee. Okay, good. Squee what? 460. Okay, the next one, sorry, 2460 to the power 2753. 2460 to the power, that is 1717. So here I can also detect errors, because if I now get numbers that are, remember this we have to consider this as two pairs of 2-digit numbers, and in fact two pairs of numbers between 0 and 25. So if I get, for instance, 6315, I know there's something wrong because 63 doesn't represent a letter. Okay, so 1717. Okay, what is that? 1717. That will be probably 17. What is 17? That's R. R. Oh, I know. I see the word. You know, this is now we're in what is this called? Not Jeopardy. The other one. territory, right? Yeah, complete the word. It skips me now. Okay, so the next one, the last one is 2550 to the power 2753. 2550 to the power, the wheel of fortune, that is what it is, okay, 411. Now, that 411 stands actually for 0411. 04 is E, and 11, I'm very sure that is L, yes. Okay, so he was talking about a squirrel, all right? Okay, so this is something. This is the way I also will ask you. I will ask you to set up the whole thing. So calculate. I will tell you what to. I will tell you. I'll give you. Say these are the things that you have to do. I, of course, will tell you also what the primes are, or what's your stock, right? And then you have to set up everything. You have to encrypt the message, and you have to be able to decrypt the message. But for that, you have to be able to calculate D. Okay, that will be the quiz. But I'll do another review similar.